Okay, here we are on the word problems section. Distance, rate, and time problems. Remember, we always have rate times time equals distance, and we're going to break them up. These problems will all have two things where we're dealing rate times time equals distance. We're going to pick our variable based on the last question. Remember, variable right here. That's going to be on the last question. And then our plan is to fill out the box, and then the second clue will give us our equation. Let's see if we can do it. Okay, so number 40. Sean and Brittany. So there's Sean, there's Brittany, and rate times time equals distance. Let's set up our box and see if we can make our equation. Okay, so it says Sean and Brittany rode bikes for the same amount of time. Sean traveled at 10.2 miles per hour, Brittany at 13.7 miles per hour. If Brittany traveled 8.7 miles further than Sean, how long were they both riding bikes for? Get our variable first. How long were they riding bikes for? So this is our t because they are the same amount of time. That's important. So there's our variable t. Now let's put everything else in that we know to be true with numbers. Sean traveled at 10.2, so there's a 10.2, and there's a 13.7. Now at this moment right here, we've got to stop before doing this other thing where it says how much further Brittany traveled than Sean. We really need to finish filling out the table. Rate times time is distance. We get 10.2t. This is how far Sean traveled. 13.7 times t, 13.7 times t. This is how far Brittany traveled. Now, can we make an equation? Do we know something about these two? Yes. This is now, this clue right here is crucial. Brittany, 13.7t, traveled equals 8.75 further than plus Sean's 10.2t. And when we think about it in that way, Brittany traveled 8.75 miles further than Sean. Indeed, that gives us an equation. Look where we are. Happy math land. Get the t's together, subtract 10.2t from both sides, and we get 3.5t equals 8.75. Then t would be 8.75 divided by 3.5, and let's pull out our calculator and see what that thing is. 8.75 divided by 3.5, and that gives us 2.5. The time they spent was 2.5 hours. Now you could actually stick that back into the whole table and fill it out and see how far Sean and how far Brittany rode in distance, but alas, we don't need to do that right now. Okay, number 41, Rick and Mark. Let's do the same thing. We got Rick and Mark. They drove boats on the lake for the same amount of time. Rick's average was 12. Mark's was 14. Mark traveled 9 miles further than Rick. This is going to give us our equation eventually. How long were they both on the lake? So let's do it. Rick and Mark, rate, time, distance, and here's our box. Good. So we've got, what's our variable? How long were they both on the lake? So time, that's our question mark at the end. So let's fill out what we have. Rick's average was 12. Mark's was 14. Now, again, stop right there. Fill out the table. The distance he traveled was 12t. The distance he traveled was 14t. Once you have these distances, Mark traveled 9 miles further than Rick's distance, right there. And it makes an equation. The distance Mark traveled is 9 more than the distance Rick traveled. Can we solve this? Sure we can. Subtract 12t over to both sides, get the t's together, and then divide by 2. T equals 9 over 2 is 4.5 hours. Shazam! Look at that. How long were they both on the lake? 4.5 hours. And if you needed to find distances, you could put 4.5 in there and see how much distance they each traveled. All right, let's clear these up and get the others out here. That's better. Number 42, Shelly and Dave. We got Shelly and Dave here. Good. Rate times time, distance. Good. We got two of them. These are actually double rate times time equals distance. It'd be easy if it was just one person, but these are like doubles. All right. So Shelly and Dave each took a trip. Shelly drove at 75. Dave drove at 50. We can put those guys in. Dave took 2 hours more than Shelley to reach his destination. Shelley drove 25 miles farther than Dave. How long was her trip? Oh, this is a toss-up. Should we have Shelley drove 20 miles further than Dave? Should that be our thing? Or how long was her trip? I think how long means time. So how much time did she drive? That's our question mark. There's our variable. So we pick a variable. Then we fill out the table as best as we can. So how long was her trip? There's our variable. It says Dave took 2 hours more. So this is t plus 2. Fill out the table. 75 times t, she went this distance. He went this distance. Now make sure you're timesing the whole t plus 2. Now Shelley drove 25 miles farther than Dave. So we get 75t is 25 miles further than what Dave drove. T plus 2. Okay, let's recap how we got that. We picked our variable based on how long was her trip, not how far was her trip, not what was her distance, how long, how much time. And then it said Dave took 2 more hours. So that gave us this box. So then this box times that box gave us that one, and that box times that one gives us that one. So then this last sentence here says Shelley, her trip was, that's equals, 25 further, that's plus, than Dave's, which is this box right here. That's where the equation came from, and we're in happy math land. Can we solve this? Sure we can. Get rid of the parentheses. And we get 75t equals 25 plus 50t plus 100. Subtract 50t to both sides, and we get 25t equals 125. And the time then is 5 hours. So how long was her trip? It was a 5-hour trip. That means Dave drove for 7 hours. There we go. I like it. That was great. Number 43. Let's see what we get here. So we get Jalen and Haley. So Jalen and Haley, rate times time equals distance. Got the boxes here. All right. They each took a plane ride. Oh, we're up in an airplane. Jalen took 2.5 hours. Okay, that's just a number. We don't even have a variable here. And Haley took 4. Okay. Jalen's plane was traveling 30 miles per hour faster than Haley's. Haley traveled 45 miles farther. Oh boy, which variable do we pick? It tells us right here. So let's pick a variable and try to fill out as much as we know. How fast was Haley's plane? So we're going to put Haley's speed right there. Now let's read through and see how much we can fill out. How fast? Jalen's plane was 30 miles per hour faster than Haley's. So this is R plus 30. Okay, so let's continue to fill it out. So this is 2.5 times R plus 30. And this is 4R. All right, and let's get an equation. Haley, this distance right here, 4R, traveled or is 45 more than Jalen's, 2.5 times R plus 30. And look what we have. We have an equation. It's beautiful. We get 4R equals 45 plus 2.5R plus, oh shoot, what is that, 75? Yeah, good. Subtract 2.5R over here. We get 1.5R equals 45, and 75 is 120. So divide by 1.5, divide by 1.5, and we get that Haley was going 120 divided by 1.5 is 80. Her plane was traveling 80 miles an hour. Means Jalen was going 110, and then you can get the distances if you plug R right back in there. Good, excellent.